And we'll pick off where we left off on Monday. We were talking about dosage calculations on Monday and using the dimensional analysis, or in other words, just the units and any equivalencies given on the label of our product to calculate what needs to actually be administered to our patient. Well, the next step is now to go into a more complex situation, which is medication that is delivered over time. Monday, what we had done was single dosage. So if you're going to give them administer the medication to them once, or even if repeated, but single dosages at given intervals, it was still single dosages. Today, it's going to be dosages administered over time. And the most common way of doing that is for an intravenous setup. So intravenous, or from here on out just called IV, goes off of what's called a flow rate. Now, flow rate can really be set up in many different forms. For example, you might have an order for 6,000 milligrams for 6 hours. One possible way of expressing a flow rate is in milligrams per hour. If that were the case, that would be really simple to do here. We take our 6,000 milligrams over. Now, in the previous examples, it was single dosages, so we always put it over 1. But when it's a dosage over time, the denominator, or the second number in our ratio, is our time. So this is over 6 hours. Then it's a matter of taking this rate here, 6,000 milligrams to 6 hours, and converting it into a unit rate. If you recall back in Unit 2 when we talked about ratio, proportion, and rates, a unit rate is calculated by taking the number of that second value and dividing both numbers by it, both values by it. So divide by 6 on bottom. 6 hours divided by 6 is 1 hour. Excuse me. Then we also divide by 6 on top. 6,000 milligrams divided by 6 is 1,000 milligrams. So 1,000 milligrams over 1 hour, or just 1,000 milligrams per hour, is that flow rate. Excuse me. So technically that is the flow rate for this medication, or is a flow rate for this medication. But it's very difficult to calculate or set up an IV setup as a certain amount per hour. Most of the infusers and most of the equipment is set up so that you can monitor it by the minute. So it would be very handy if we could convert this to milligrams per minute. And of course, continuing from this calculation here, 1,000 milligrams over 1 hour, it's pretty simple to convert that into milligrams per minute by just converting the hours into minutes. The hours are on bottom here, so I'm going to put it on top here. Our equivalency, this is one where we have to use the standard equivalency, standard conversion. 1 hour equals 60 minutes. Hours cancel out. On top, we have 1,000 milligrams times 1. That's just 1,000 milligrams. On bottom, we have 1 times 60 minutes. That's 60 minutes. Once again, we would divide out by that bottom number to make it a unit rate. So dividing by 60 is going to give us 1,000 milligrams divided by 60. Which is going to be 16.67 per minute. Well, this is one of the methods, one of the ways of expressing a flow rate, milligrams per minute. Most of our medications, the doctor's order is based on a certain number of milligrams, or if we're going off just a recommended safe dose, those are usually expressed in milligrams as well. So we might have an order, 2,400 milligrams per hours. And let's express that in milligrams per minute. So we just start off with that order, 2,400 milligrams. And again, since we're given a time, that becomes our second number in our rate, or bottom number of our fraction, if you will. So 2,400 milligrams over 4 hours. And right now we are in milligrams per hour. We want milligrams per minute. So the milligrams don't need to change here, but the hours do. We're going to put hours on top. And once again, 1 hour is 60 minutes. So the hours cancel out. On top, 2,400 milligrams times 1 is 2,400 milligrams. On bottom, 4 times 60 minutes is 240 minutes. And then, of course, we divide those out. We divide both by 240, giving us 10 milligrams per minute is that flow rate. Well, if we have a computerized or electronic infuser, we might get away with typing in 10 milligrams per minute and then entering the other information, the concentration and stuff of our medications. However, most of the time we're not dealing with that. If we have a manual infuser or just a mechanical infuser, not non-electronic, we have to set it up as a volume rather than a mass of fluid that's administered over a period of time. So if we have an order for something like 4,000 milligrams over 8 hours, and our label on our supply says the medication is constituted at 25 milligrams in 8 milliliters. And our device, our infuser here, requires the setup be done in milliliters per minute. This is going to require one extra step in our process. So we start off with the order still, 4,000 milligrams over 8 hours. And we still need to change the time from hours into minutes. So let's do that first. We'll put hours on top. 1 hour is 60 minutes. Hours will cancel out. And we're now in milligrams per minute, but we want milliliters per minute. So we have to convert the milligrams into milliliters. Well, right now, milligrams are on top, so we're going to put them on bottom so they will cancel out. And we look at our label, 25 milligrams in 8 milliliters. 5 goes with the milligrams, 8 milliliters will go on top. So again, we cross-cancel units. The milligrams have canceled out. Now, the only unit we have on top is milliliters. That's what we want. The only unit we have on bottom is minutes. That's what we want. So we're ready to multiply this out and then reduce it or divide it up. So on top, we have 4,000 times 1 times 8 milliliters. 32,000 milliliters. On bottom, 8 times 60 minutes times 25. I believe that's 1,200 minutes. I need to double check that. $12,000 minutes, forgot a zero. Glad I double checked it. So we have 3,200 milliliters over 12,000 minutes. We need to divide that out now to get into milliliters per minute. Now remember, technically what we're doing is we're dividing both of those numbers by 12,000. And we know that 12,000 minutes divided by 12,000 is going to be just 1 minute. But from here on out, we're going to stop doing that explicitly, and we're just going to divide it out. We're going to do the 32,000 divided by 12,000, which would give us 2.67 milliliters per minute. Let's do one more example of that. Let's say we have an order for 3,600 milligrams medication to be administered over 8 hours. Look at the label on our supply, and it says that that medicine is constituted at milligrams in 12 milliliters. So again, let's find our flow rate in milliliters per minute. So we start out with the order. 100 milligrams over 8 hours. Next, we'll get rid of the hours. Hours go on top so they cancel. 1 hour is 60 minutes. Milligrams per minute, which is close. The minutes are good. We just need to get rid of the milligrams. Milligrams are on top, so we're going to put it on bottom here. And we have that relationship on the label, 50 milligrams, 12 milliliters. So 50 milligrams is equivalent to 12 milliliters. Now we cross cancel, the milligrams are gone. Right now we have milliliters on top, that's what we want. Minutes on bottom, that is also what we want. So let's go and calculate this out. 3,600 times 1 times 12 milliliters. That's 43,200 milliliters, but I'm going to check it. This, cool. Over 8 times 60 times 50, which is, I believe, 24,000 minutes. Yes. So now again, I'm not going to go through the long process of creating the unit rate. I'm just going to divide it out. We would divide out 43,200 divided by 24,000 to give us 1.8 milliliters per minute is that flow rate. Now 1.8 milliliters per minute, it's a small number for milliliters, but that actually could be a pretty considerable flow rate. If you're dealing with an electronic infuser, that's most likely just fine to just enter 1.8 milliliters per minute. The infuser has sensors and stuff to do everything else that's needed to infuse that medication. But depending on how advanced the setup is you're working with, if you're dealing with one of the old ones, the old IV setups where you actually have the little glass bulb in the middle of the tubing, and you watch in that glass bulb, you actually count the drops and time it to see how many drops go through, and then you have the screw clamp to pinch down the hose or release the hose more to let it flow faster or slower. You have to set up that flow rate using that device, and you have to count not milliliters, but you have to count drops that drop through that bulb in the course of a minute. So having the flow rate of milliliters per minute is acceptable in some cases, but depending on the type of infusion setup you have, you might need to know this in drops per minute. So, talk about something called a drop factor. Drop factor really just goes off of the viscosity. Viscosity means thickness, but it's more than just thickness, it's the thickness and surface tension of a fluid. In other words, if you put it in an eyedropper and you squeeze it till a drop comes out, it's literally how much fluid is in that drop. Well, a drop factor actually goes the opposite direction. It says how many of those drops does it take to make 1 milliliter. It's the number of drops of that fluid in a milliliter. Drop factor typically can range from 6 to 20, depending on the properties of our medication. Typically, we deal with 8 to 16, 8 to 18, about what we end up dealing with. Really thick fluids actually can have fairly large drops to get down to that 6 to 8 drop per milliliter. And thinner fluids with a low surface tension can get up into the higher numbers. For this example, the one that we just calculated up here, let's say that on that label, add that this is drop factor, this fluid of 18 drops per milliliter. Now that GTT there, if you recall from page 150 of your textbook, looking over those abbreviations, GTT is the abbreviation for drops. I really do not know where it originated from, but that's what it stands for. So I have my 1.8 milliliters per minute. I can use this drop factor of 18 drops per milliliter. Remember we had said before that any rate can actually be converted into a measurement equivalency. 18 drops per milliliter means that 18 drops equivalent to 1 milliliter. And I can use that as a conversion factor. I'm getting rid of milliliters, so I'll put milliliters on bottom. 1 milliliter is equivalent to 18 drops. Milliliters cancel out, and on top I have 1.8 times 18, which is 32.4. Drops, minutes times 1. I should have thought it was 1 minute times 1 is just 1 minute. So my 1.8 milliliters per minute flow rate for this medication with that 18 drops per milliliter drop factor comes 32.4 drops per minute. So again, if we're looking at that little bulb, watching the drops drip through it and counting as we time a minute, we're looking at counting between 32 and 30 drops in that 1 minute of time. So here we put 32.4. Well, we really can't count 32.4. Rounding for drops per minute really depends on the type of device we're working with. If we have a manual infuser, which is the setup that I just described, it's literally the glass bulb in line of the IV, and you got to count the drops dripping through that bulb. Or a mechanical infuser. Either of those, the industry standard, could round nearest 1 drop per minute. If you have an electronic infuser, and electronic infusers have a pretty wide range of fairly simple to highly computerized. Those typically allow you to round to the nearest hundredth of a drop per minute. In here, because you can always round a number more, Once you've rounded it, you can't get that information back without redoing the problem. So since you can always round a number more later if you need to, we're going to go with the more precise measurement. Our standard is going to be to go to the nearest hundredth of a drop for this course. So let's do this all in one process now. If we have an order for 3,000 grams, administered over 12 hours. Our supply has a label of 25 milligrams powered, or 12 milliliters. And a drop factor of 8 drops per minute. So this is a relatively viscous fluid. And of course, we want to know in drops per minute what our flow rate is going to be. So as always, we'll start with the doctor's order, 3,000 milligrams for 12 hours. And just as we did in each of the previous examples, since we have to change the time from hours to minutes, that's going to be our first step, is to go from hours to minutes. 1 hour is 60 minutes. Put the hour on top so that it cancels out with the hour on bottom. Now let's start looking at our units. If you're in milligrams, so I'll put milligrams on bottom, and I need something that relates milligrams to something else. Up here, 25 milligrams and 12 milliliters. Remember, that is saying basically 25 milligrams is equal to or equivalent to 12 milliliters. I put the 25 milligrams on bottom to cancel out the milligrams. 12 milliliters on top. The milligrams cancel out. Now in milliliters per minute, well, I want it to be per minute, but I want it in drops per minute. So I still have to change the milliliters to drops. Milliliters are on top, so I put them on bottom to cancel them out. My drop factor is 8 drops per milliliter. Again, that is saying 8 drops is equal to 1 milliliter. So 1 milliliter and 8 drops goes into my linear process here. Milliliters cancel out, and now I have drops on top and minutes on bottom. That is exactly what I want. So on top, 3,000 times 1 times 12 times 8 drops. Gives us 288,000 drops. Over on bottom, we got 12 times 60 times 25 minutes. And then again, we have to divide that up. 288,000 divided by 18,000 thus 18 drops per minute is what we're going to set up that infuser at. I'm going to have you guys try one of your notes here quick. How you do on this? So we have an order, 6,000 milligrams, be administered over 10 hours. Our label on the bottle says that we are 30 milligrams, 7 milliliters, and we have a drop factor of 14 drops per milliliter. Find my flow rate in drops per minute. I'll give you a couple minutes, then we'll go over that. Let's take a peek, see how you're doing here. We'll start out with the order, 6,000 milligrams in hours. We get rid of the hours first again, as we usually do. So 1 hour, 60 minutes. Giving us now in milligrams per minute. Milligrams are on top, so to get rid of them, we'll put them on bottom. 30 milligrams, 7 milliliters. Grams, well, and finally, get rid of milliliters, drop factor. 14 drops per milliliter means that 1 milliliter is 14 drops. Milliliters cancel out, and we now have drops per minute, which is what we want. So on top, we have 6,000 times 1 times 7 times 14 drops. $588,000 drops. If you were counting, by the way, that 588,000 drops, that would be actually the total number of drops administered over the whole 10 hours. On bottom, then we got 10 times 60 times 60 minutes times 30. 18,000 minutes. We would take 58,000 divided by 18,000. 32.67, we'll round that to. Drops per minute is our infusion rate. Give me a wave. How many of you had that correct? Anybody have any questions on that? We'll go over more examples as we go. Next example, I actually wanted to give you an example of how it could actually be a little bit more difficult. Let's say we have an order from our doctor of 400,000 units of heparin administered over 4 hours. This is kind of like what we ran into on Monday where we had units or milli equivalents. We didn't really know what that unit really stands for, but we don't have to. We can use the other information to convert it to something that we do know how to administer to the patient. Let's look at the label on our supply here. Will tell us 1 million units is constituted at 50 milligrams, 12 milliliters, and as a drop factor of 15 drops per milliliter. So as always, we start with the doctor's order. 400,000 units. Per hours. And like we've done with pretty much every other example, we'll start by getting rid of the hours. 1 hour is 60 minutes. Hours have been canceled out. Now we need to get rid of that weird unit of units. On the label, it said 1 million units, so units are going to go on bottom to cancel those out. 1 million units on bottom in grams. Units have canceled out. I'm also going to cancel out 5 zeros. I'm going to divide by 100,000, so this is going to be 4 here. Dividing out 5 zeros here will make that just a 10. But we are still in grams per minute, which is not what we want. We need to get to drops per minute. We have to get rid of those grams. We do not have any units given in the problem, any conversions or equivalencies with grams in them. So I'm going to convert to a standard conversion, 1 gram, 1,000 milligrams. Now that if I'm in milligrams, I see that I do have a conversion up here. I have 50 milligrams into 12 milliliters. So I put my milligrams on bottom, 12 milliliters on top. That will cancel out the milligrams. I am currently in milliliters per minute. I need to get to drops per minute. So I have to go one more step, and that's my drop factor. 15 drops per milliliter, saying 1 milliliter is equivalent to 15 drops. Milliliters cancel out, and now we can go ahead and multiply this through. 4 times 1 times 2. Calculator up, so I just type these in. 1,000 times 12 times 15 gives us 1,440,000. Drops over on bottom. We got 4 times 60 times 10 times 50 times 1 gives us 120,000 minutes. If we divide that out, drops per minute. 12 drops per minute is what we would set that up to flow into the patient to meet the doctor's. So as you can see in all of these problems, we just start with the doctor's orders, and then we let the units tell us what to do from there. If the unit in our thing is not what we want, like we didn't want hours, we wanted minutes, so we canceled out the hours and converted it to minutes. Didn't want units, we wanted drops, so we canceled out the drops, we canceled out the units, and we converted to whatever we had an equivalency to go to. We didn't necessarily know, we didn't go to drops, but we knew we had to get rid of units. So whatever equivalency we had that converted units into something else we used, and we kept getting rid of whatever that new measurement was until we got to the drops that we wanted it to be. And that's how dimensional analysis works. This day, I honestly still don't know exactly what the meaning of a unit is. I do know it's different for every medication, but I don't have to because you read the specifications that allow you to convert from the units into a more usable measure. So our next step, final step for today, is to look at reverse calculations. As we are working with IVs and whatever, sometimes we have we can look at the machine and see what somebody has set the machine at, has set the infuser at, but there's other information that might either didn't get recorded on the chart or that we need to know that we have to figure out. One of the big ones of those is infusion time, or time to infuse. We might know the doctor's orders, but maybe the bag of medication was not big enough to fulfill the whole order. So we may need to figure out how long that medication, that bag is going to last, so that we know if we need to change it at some point before the order is complete. So if we have an IV bag containing 2,400 milligrams of medication, and we look at the label on the bag, and we see that it is 40 milligrams, 15 milliliters. Drop factor, 19 drops per minute per milliliter. And we see that the infuser is currently set at 45 drops per minute. How long will it be before that bag is empty? In other words, at what time or how long from now do we need to come back and change that bag? Do this calculation. We are looking for a time, which means we have time on top. Our setup here of drops per minute, not have time on top. It says 45 drops equivalent to 1 minute, which means I can always flip that over and I get a true rate. Think of one of our more common rates that we work with is driving. If you are driving 50 miles per hour, it is also true that you drive 1 hour per every 50 miles. You can reverse the rate or take the reciprocal of that rate and it will still be true. So that setting of 45 drops per minute can be changed to 1 minute for every 45 drops. And now we can convert. Well, minutes is what we want. We want time. So let's get rid of the drops. We'll put drops here. And we need to find something else that relates drops to something else. Well, we have that right here. 19 drops per milliliter. That's saying 19 drops is 1 milliliter. Drops are canceled out there. We need to get rid of milliliters. Milliliters are on bottom, so I'll put it on top. Here we have 40 milligrams and 15 milliliters. So that's saying 15 milliliters is equivalent to 40 milligrams. The milliliters cancel out. We now have minutes per milligram. And we look at the doctor's order here. That is for 2,400 milligrams. And we just put that over 1 because there is nothing else related with that. But it will cancel out the milligrams. So on top we have 1 minute times 19 times 15, 2,400. Give us 684,000 minutes. On bottom, we have 45 times 40, which is what? I believe it is, and then we divide that out. Because 380 minutes is that time. Now, of course, we can convert that from 380 minutes into hours. Minutes over 1. 1 hour is 60 minutes. Minutes cancel out. We have 380 hours over 60. Divide that, that is 6 1/3 hours. Or 6 hours and 20 minutes. Well, this is not the only way we could have completed this. I started with the 1 minute over 45 drops because I knew I needed time. So I wanted to start with something that had time on top. But we don't really have to do it that way. Could have started with the amount in the bag of 2,400 milligrams and just put that over 1 to make it a fraction. And we could have worked from that. Get rid of the milligrams. Well, we had 40 milligrams and 15 milliliters. Milligrams are canceled out. After you get rid of the milliliters, well, we have 19 drops per 1 milliliter, so the milliliters will cancel out. And then to get rid of the drops, then we could have used the flow rate set up here, where we were set at 45 drops. I'll put 45 drops on bottom per minute. Notice this is almost exactly backwards from what we did before, but we get the exact same numbers. Drops cancel, we get 684,000 minutes over 100, and it divides out to be 380 minutes or 6 1/3 hours. The key is you could work from either end. Up here, I started with the 1 minute over 45 drops because then I knew I had minutes on top, and it guaranteed that when I got to my answer was going to be in a unit of time. Starting here with the amount in the bag is a little bit riskier because I don't know where the time is going to end up. But the worst that can happen is I get to the end here and time is on bottom. And remember what we said, any rate can be flipped over and still be a legitimate rate. So if we had come up with an answer like 1,800 over 684,000 minutes, no, that is equivalent to this. So we could have just flipped it over and divided it out then. We'll do more with those reverse calculations over the next several classes. For right now, your homework in the book, page 178 through 179, problems 1 through 21, odds, be enough there, are dealing with these IV flow rates. If you do the odds and you're doing very well on them, great. If you're struggling, feel free to go back and do the evens. If you have any questions on these, please let me know on Friday and we can go over them. Feel free to interrupt me at the beginning of the class and let me know that you want me to go over any of these problems. With that, you all have a great day. Hopefully we'll see you all on Friday.